I printed waterproof sink. My older cat completely ignores his 5 water bowls. His guilty pleasure, of course, drinking from the tap, so I decided to make him a DIY pet fountain. I'll be using marble PLA filament from our local supplier. It's pretty affordable, has awesome texture and really easy to print. However, the idea for the project came to me when I found this compact water pump. It costs just a few bucks and can push water up to half meter high. I'm gonna leave the link in description. The best of all, it's completely silent, at least for human ear. Plus, it fits perfectly into a standard food container that you are able to buy anywhere and probably have at home. For the controller, I'm gonna use ESP32 Wroom. While it's probably overkill for such simple projects, I already have several ones. And its Wi-Fi feature comes in handy when cat is demanding for water and you are too lazy to turn on the fountain manually. Since both pump and ESP32 run on 5 volts, I'll power the whole project through a Type-C connector. Last but not least, I need NPN transistor and a manual switch button to control the pump. And almost forget, I also need some connectors, crimping tool and of course wires. Let's start from the modeling. I jump into a Fusion 360. I'm using my sink as a reference because cat used to it, and actually I like how it looks. The sink and tap are designed at 1:2 scale. Everything will stand on a laminate floor I saved from my flat renovation. Printing everything took me around 15 hours and half kilo of filament. And to be honest, I'm really happy with the printing quality, though I can't eliminate the seam between the two parts. On the background I tried to sand it, but seam is still visible. Painting is not an option too, so I decided to accept that fact and move on. Since I couldn't find any fully waterproof filaments available, I went with coating the sink with epoxy. Okay, before you start complaining in comments, I want to ensure you that I used food-safe epoxy and cat safety come first. But to tell you the truth, I had some concerns about this approach, because epoxy would run down the walls and I had no idea how to spread it evenly. ChatGPT wasn't much help either. For example, building a machine to rotate the sink sounded like overkill for a single project. Taking that into consideration, I decided just to try. Before applying the epoxy, I glued the two parts together. Next, I installed the drain and sealed the hole. I'll open it later to get rid of extra epoxy. I covered the sink inner walls with mixed epoxy, carefully spreading it across the surface. As was expected, it flows down. So I tried to rotate the sink, spreading epoxy again and again and again. It took almost 30 minutes of spreading before the epoxy reached the right thickness. After letting it dry overnight, I had a beautiful shiny waterproof surface. But unfortunately, in battle with epoxy flow, I totally forgot how to get rid of small bulbs. I assumed that the best option was to heat surface. Let's jump to the platform. I'm more skilled at printing than woodworking, and all I have is a blunt knife to cut the laminate. I'll spare you from watching that creepy part, so I hope you appreciate this gesture and subscribe. The two laminate panels connect with simple joints. I considered making a closed box with a revision door, but decided to keep things simple. Okay, I'll be honest with you, the real reason for using such columns is printing cost. Using almost a kilogram of filament for the walls didn't seem like a good idea. My personal best in the project, this cute button. Hoping my cats are clever enough, I printed it. I have no AMS, so it's 6 separate parts connected together. Inside the tap, I've used a food-grade silicone hose. I slightly miscalculated, so the construction isn't as tight as I'd like due to a hose bend. The final step is coding. ChatGPT helped me connect ESP to my home Wi-Fi. Once connected, it creates a web server with a configuration page. When the button is pressed, pump runs at set time. Pressing the button again stops the pump. The run time can be changed through the web page. After uploading the firmware, I'm testing the config page accessibility. All the electronics fits a small box. I'm using a connector instead of soldering to attach the pump, making it easy to detach and clean. The connector and Type-C inputs fits perfectly, but I added a few drops of glue. After final assembly, I'm ready to test the device.